Hi all, this is an additional video for the Waterjet. We're going to cover a few of the things that we found to be important now that we've used the Waterjet for a bit. One of those is clearing a clog in the event that water rushes back up the tube while you're cutting. That happens more frequently than we expected, so it's important to know how to fix that. The second thing we're going to touch on is adding your own materials in layout so that if you're cutting a kind of steel that isn't covered, something like that. We're going to cover, I don't think I was clear about the difference between hard and soft limits and how those work, so I'll touch on that. Just gonna home like normal here. I've already brought the machine pretty close to where it needs to go. We don't need to raise it. Begin homing. Coming over here, it's doing its thing. So right here, this is one hard stop. There's the same thing on the other end for the x-axis, and that means that this piece of metal is literally gonna hit up against here. So it's bringing itself to the edge, and that's how it's finding its location in the machine. So it's gonna push up, feel that resistance, and that's the hard limit. That's also what's stopping the mixing tube here from whacking against the tank, is that hard limit. So, if you were somehow to exceed the soft limits, that's how it would stop itself from breaking itself there. Once it's done that, we're gonna push pause. And now it's gonna go to Y, and for Y, this is the hard limit, the head of this bolt. So it hits a piece of metal under there, and that's the hard limit for Y, how it knows how it can't exceed that and where it knows its limits are. So then the confusing bit is how it transitions from those hard limits to the soft limits. Soft limits are imposed by software, so it is telling it that it can't exceed that cutting area. And that cutting area is within these aluminum bars, so it can't come over here. The machine can, but when soft limits are enabled, it doesn't let it. And then over to here, and the limits of the grate effectively within there. So now it's found Y, we'll hit pause. So on the screen, you can see that it says soft limits are disabled. Oh, there we go. So it used to say soft limits are disabled before we had homed, because to home, you need to exceed those soft limits. And here it says that the soft limits have been hit. So what we're gonna do is we're gonna move away from those. So we're now gonna come off. So now the Y soft limit is no longer being hit. And now the X soft limit is no longer being hit, and we're within the constraints of the soft limits. So now if I tried to go back to where we were, it won't let us. It's gonna stop right there because it doesn't want us to be able to hit the aluminum. So now that we've gotten within those soft limit areas, we're constrained by it. But you have to manually go from those hard limits into the soft limit area. So that's the first thing I wanted to cover. The second we'll look at is materials, because that's pretty simple, and then we'll get to the more involved ones. So let's say, here's an example of a material that was added by a member. So this is 1084 carbon steel with its hardness listed. And so this was added, and this number, the machinability, is a function of its hardness, of its excuse me, a bunch of other factors. And for a metal, it has to do with whether it's hardened or whether it's annealed or tempered or whatnot. So that's a number you have to kind of look up and figure out online. There's a little bit of a fudge factor involved there. And here is where you can add a new material, you can edit it, and I would just recommend mentioning when you make this in the note that, maybe who added it, your name, so that people can, ask you if you have ideas. You just put it under a category. Here you can also, there's machinability charts, there's other materials. So, this can be useful to get a sense of different things. But yeah, I would recommend looking it up online for what other people have found. Okay, so that's going to lead us to, let's do the clogging, because that's probably the most important piece. So what happens is, like 99% of the time when the cause of this problem is the material is not clamped well enough, or it isn't flat for whatever reason, and so it comes up and it pushes up against the bottom of the mixing tube. Just one-handed is difficult. So it pushes up against the bottom of the mixing tube, and now all that water pressure can't come out the bottom, so it shoots out here. When it shoots out here, it goes up our hose and into the abrasive hopper and makes that garnet wet, and then it clogs and can't come out. And so then it's just water spraying everywhere. It's a mess. So you whack the pause button, and then you need to figure out how to deal with that. So the reason that happens is, one, because let's say we clamped here and then our material is bopping upwards, so we need to clamp it in such a way that the material is held flat. Another is if the material isn't clamped well enough, the water goes through and the water wants to go somewhere, so it rushes up around it and lifts the material. The water will lift the material up and push it into the bottom of the mixing tube. And so the remedy for that is we've tried a few different ways, and I think that the best one I've seen is this. So what you want to do is you want to clean all the wet garnet out of here, and you want to dry this hose, and then just blow some of the water out of here. So it isn't that hard, but it does require a little bit of finesse. So I figured it makes sense to show you what this looks like when it happens. So I've set this material here, I calibrated the height, and I'm just going to leave it unclamped. So what will happen is the material will come up, or maybe I'll put one clamp over the end so it doesn't move, but it'll still come up. And so you can see what that looks like. Another cause is your material could just be not flat, or you could have calibrated it too close to the surface. If for whatever reason it touches and hits. So I'm just going to hit saw just to make a quick cut downwards, and we're going to cut 2 inches and click. And I'll put the little shroud down so it's a little more dry. And go. So that's what it looks like. The water just shot right back up. In this case, I had the tip lowered a little more than normal just to exaggerate it, but it's the idea. So the way we're going to go about cleaning that, now that the water is shot right up the tube, is by taking this red plug, which lives in the second drawer of the tool chest, or the Waterjet computer, and putting it in there to replace this guy. So I brought the air hose here so it's easily accessible. And the trick, so we can unplug this, and some, well, water didn't pour out, so we're going to just pull this out, and in this case a whole lot of garnet just poured out, which means it isn't clogged up in there. If it were clogged in there, you can use this air hose just to blow a little of that clog out, and it should come pouring out. So you're going to take the red plug and push it in there. Okay. And then we're just going to dry off all the components. So you're going to take this hose out, blow some air through it. Obviously be careful not to blow it out anyone or yourself. So dry that out. I'm going to dry this guy off. Get it right in the face. Alright. The main route that we care about is the abrasive going in here and out here. So I'm just going to use my finger to plug the hole in the back and blow that out. So get the rest of it off. Just want to be extra sure that it's clear. And then we're going to also blow the schmutz out of here. So I'm just going to from that hole and this hole in the side. Maybe put our finger on that. Just make sure that's clear. Alright, and now putting it back together, we're going to put this back in, take the red plug out, maybe plug with our finger. And put this back in. and the hose back in, and we'll do a test to make sure that it's still going. For the test, I'm just going to raise it up a bit to clear, to make sure we aren't immediately pushing it right back in. Let's say this happened during the middle of one of your cuts. What you can do is on the screen here, if you right click on begin machining, it will let you continue from path interrupted home. So let's say you were doing your cut and then you needed to pause it halfway through, then this would be black and you could go back to your path interrupted spot so that you didn't need to recut your whole piece. So I'm gonna put that there, and then I'm just gonna do a test, the test cutting head, next, go. All right, so I cleared that out. Now I'm gonna go over what to do if it wasn't that easy. So let's say that water really got all the way up in there. The steps that you would go through are to turn the air off underneath the big hopper. So you would turn this off so the air is no longer pushing garnet through. Then you would undo this and do a lot of the same things there. Undo this strap, and what would happen is some of this garnet would come out and then you just let it fill up there. Then you could take this off, remove this grounding strap, and then using a 6mm Allen key to loosen this while you are holding here. So then it will release this hopper and you can pour this material, the garnet, back into the big hopper through the screen. And then if there are any chunks, just make sure to dump that out. And then use the air hose to blow out the inside to make sure it's super dry in the inside. Don't want to lose this guy. And then you would reassemble it, and that's how, if there was water way up in here, you would clean that out. And then when you're done, you put this hopper back in, tighten it, put this back on, put the grounding strap on, and you should be back in action. Most of the time, that shouldn't be necessary. Taking this bottom plug out should be all that you need to do. That's the process.